The rectangular gate AB shown is 1.5 meters wide into the screen. Find the net force on AB and specify its line of action above B. The specific gravity of glycerin is 1.26. So this is the figure. There are two liquids on the side of the gate. We have water on the left side, glycerin on the right side. The glycerin is denser than water, but the depth of water is higher, so we expect force on the water side is greater than that of the glycerin side. So therefore, the net force would be force of water minus force of glycerin. So let's locate the center of gravity common to this gate here, and this is the center of pressure of water, because if barred H is higher, E would be lesser. E is the distance from centroid of area to center of pressure of water here. And this is E, centroid of gate to center of pressure of the force due to glycerin is greater because barred H of glycerin is shorter or smaller. So this is 1, 1 because the height of the rectangular gate is 2 meters. So the centroid is 1 meter below A and 1 meter above A. So there acts F of water, then here acts F of glycerin. So we expect that the net force would be somewhere there. And we will call the distance of the net force from the bottom B as HB. So we're looking for F net and HB. So F net, summation forces horizontal, is F water minus F of glycerin. F of water is 9.81, barred H is 3 plus 1, 1.8 plus 1.2 plus 1 is 4, then area 1.5 meter perpendicular to the screen by height 2 meters. So F water is 117.72 kilonewtons. Then F of glycerin is, barred H of glycerin is 1.2, 1.2 plus 1, 2.2. So 1.26 times 9.81, barred H 2.2, area 1.5 by 2. So F of glycerin is 81.58 kilonewtons. Therefore, F net 117.72 minus 81.58. So the net force is rightward and it is equal to 36.14 kilonewtons. Then by Varignon's theorem, we sum up moment about B equals 0. But before that, let's solve for E of water and E of glycerin. E of water is height of rectangle 2 square over 12 barred H of water. Barred H of water is 4 above. So 1 over 12 meter. E of glycerin is 2 square, same height, over 12 times 2.2 barred H. So it is equal to 5 over 33 meter. Then, by Varignon's, F net times HB equals FW times 1 minus EW minus F of glycerin times quantity 1 minus E of glycerin, because this is E of glycerin. So the distance of FW from the bottom is 1 minus EW. The distance of F glycerin from the bottom is 1 meter minus E glycerin. So substituting 36.14 HB equals 117.72 quantity 1 minus 1 over 12 minus 81.58 quantity 1 minus 5 over 33. So using your calculator there, HB is 1.071 meter.